Hi, today I'm going to give a basic tutorial concerning the use and operation of multiplexers and demultiplexers. Multiplexers are a component that allows one to choose which input is passed through to the output. The symbol for multiplexer is shown here. As you can see, it has multiple inputs and only one output. Additionally, there are two special inputs located here at the bottom. These are the selector inputs, the selector bits. They decide which of these inputs is passed through to the output. The truth table on the right here displays this relationship. For example, when BA is 0 and 0, the output will be A, or the first input. When BA is 0, 1, the output will be B, or the second input, and this continues so on, so on. Each combination of these selector bits represents an input in binary. So since this is a 4-to-1 mux, meaning 4 inputs and 1 output, the selector bits need to represent 4 different numbers in binary. Now onto the design of the mux. The gate level schematic shows how the selector bits are related to the inputs. For example, if B and A are both 0, they will be passed through the inverters, and the only AND gate which has the possibility of outputting a high logic level would be this first one here. This one is connected to input A, so the only possible output at Q is A. Now that we understand multiplexers, let's move on to demultiplexers. Demultiplexers are just the opposite of muxes. They allow one to decide which output the input is sent to. The symbol for the demux is just a reverse mux with the outputs on the right and the inputs on the left here. It is exactly the same in that there are still selector inputs, the number of which is determined by the number of possible outputs. The truth table on the right here again shows a relationship between the selector bits and the output. When BA is 0, 0, the selected output will be A, since this is the first output. When it is 0, 1, the selected output will be B. And when BA is 1, 1, F will be sent to D, since it is the last or the fourth output. The gate level schematic of the demultiplexer is now shown. It is essentially a reverse multiplexer. The structure is almost entirely the same, except that the outputs of the AND gates are not sent to one final OR gate and then sent to one final output. Each of the AND gates receives the same input F as well as the selector bits. So when AB is 1, 1, both of these will send a high signal to D, or not to D, but to the AND gate associated with D. Then, so the only possible output that can have a high logic level is D. So F will be sent to D. I hope this helped your understanding of multiplexers and demuxes, and that you understand the operation and design of them a little better. Thanks.